Universal law of gravitation. We may take it for granted now, but more than 300 years ago, Sir Isaac Newton proposed a revolutionary idea that any two objects, no matter their mass, exert gravitational force towards one another. This law is represented by an equation that many high schoolers encounter in physics class. It goes as follows: F equals g multiplied by m1 m2 divided by r square. We can explain this equation in words. The force of gravitational attraction between two objects is equal to the gravitational constant multiplied by the product of their masses, divided by the square of the distance between their centers. This equation is known as the universal law of gravitation and is a fundamental principle in physics that explains the force of gravity between two objects. F is the gravitational force between the two objects, measured in newtons. m1 and m2 are the masses of the two objects, while r is the distance between them. G is the gravitational constant, a number currently calculated to be 6.672 times 10 to the power of negative 11 Newton meters squared per kilogram squared. The benefit of the universal law of gravitation is that it allows us to calculate the gravitational pull between any two objects. This ability is especially useful when scientists are, say, planning to put a satellite in orbit or charting the course of the moon. The universal law of gravitation has been observed to be accurate at both the macroscopic and microscopic levels and is the basis for many important calculations in astrophysics, including the motions of planets, stars, and galaxies. It also plays a critical role in the study of gravitational waves and the behavior of black holes.